Hello, my Calc 3 student. I really miss you. And today we continue work, and this is section 14.a, who is change of variables and Jacobian. How it's work? First, we need definition. What does mean Jacobian? If x is some, you can rewrite like some function depend new variable u and v, and y is, you can find function for depend the same new variable u and v. U is not looks like u, sorry. Okay, u and v. Then Jacobian of x and y with respect to u and v, denoted this one symbol we use, x, y. V. It will be the derivative x for du, first column derivative x for dv. Sorry guys, I'm how I mixed up, I don't know. I'm switch column and row. It will be dx dv and dy du dy dv. One more time. First row it will be derivative your function x. First element is will be derivative your function x respect u. Second column is derivative, second column first row, it's derivative your function x respect v. Second row first column dy du. Second row second column dy dv. Okay, and what does give us? This means here we have, if you have some double integral from some region R from function f depend x and y dA, this well, maybe we write dx dy, it's better because here we need exactly how it's we changing dx dy. It will be integral. Here I'm not write region R, I'm use different symbol, but it's same region, but as border now we write use new variable u and v. It will be f, from x we plugging g u v, for y we plugging h u v. Then we have absolute value your Jacobian, the Jacobian of x, y respect, oh my god, respect u, v, and then we have du, dv. Okay, I think it's better if we are looking for some example. But before we start solving, you remember when we moved to rectangular to polar coordinate system, we have in the formula some r. But because we're moving, use Jacobian before we now about Jacobian. Okay? Try counting Jacobian if you move from rectangular to polar coordinate system. What we have here? Okay. Remember, axes are cosine theta. Y is r sine theta. Now dx dr will be only cosine theta. Dx d theta will be derivative cosine is negative sign. This means minus r sine theta. Dy dr will be sine theta, and dy d theta will be derivative sign is cosine. This means r cosine theta. Now if you want to x y counting Jacobian r theta, we need count. First row it will be cosine theta negative r sine theta. Second row it will be sine theta r cosine theta. And if we count, it will be r cosine square theta plus r sine square theta, which give us exactly r, because r take out cosine square plus sine square is equals 1. You see, this means now we understood where it come these formulas. Okay, try solving some example when we need evaluate. This is example 19 from your section 14.8. This example show us how we make our border, our region is more simple, and how it's help us counting integrals. Okay, let's go. We have this kind of region. It will be, it's number 19 for 14.8. And here you have two lines. One is, okay, maybe I write this out. Y equal 1/2 x. One line, okay, believe me, it's line. Y equal 2x. And two curve. One is curve is y equal what is I have arrow here, sorry. Y equal 1/x, and one more, I have y equal 4/x. And we need found something for this two region. Found some integrals. And integrals are, it's not so simple. It's mean we have integral r e to the negative xy over 2 dA. This means first we need doing some our region more simple, and same time we need save our function is so simple. Okay, here they suggest us, I clear my region here. You have some graph there. X is square root from u over v, and y is square root u times v. Let's come from our region, because some of them as f over y over x you can write as line, and for example y equal to x, this means y over x equal to, and some of them it's will because you can write as product. Okay, show you how it's work. For example, y equal to x, you have as one as border y equal to x. Then we plug in, it will be square root uv equal twice root from u over v. Try simplify, square root u and u cancel it, and you have v equal 2. Second line, y equal 1/2 x. Same plugging for y, square root uv, and plugging for x, that's 1/2 square root u over v. You have v equal 1/2. You see, v changing between 1/2 and 2, because we say this is 2 borders your region. V change from 1/2 and 2. Okay. Use curve. This is we use line to line in a border our region. Use curve. You can see y equal 1 over x. It's mean xy equal 1. And if you multiply it here, you have square root u over v times square root u v equal 1. It's mean u equal 1. Y equal 4 over x. This means xy equal 4. And that's mean, okay, u equal 1, sorry. This mean plugging, and same you have u equal 4. Now we have u changing between 1 and 4. We have new border, our new border for our integral. Our region is much easier, you see. It's like rectangle. We change between 1/2 and 2, you change between 1 and 4. Now we need counting Jacobian, and then plug for function and see what kind of integral you have. Okay, I'm clear here, and we're ready for count our Jacobian. Jacobian will be dxy duv, what we have here. Okay. First row. Take a derivative x respect u. Guys, I think I make mistake. I think I switch here, x and u, but we have it's great here. Okay, we can continue there. Respect x with, because I think it's in the book they show us, suggest us, x is v over u. I'm due to u over v. It's no big deal. We can continue solving how I solve. Okay. X respect u. U is 1/2. V is negative 1/2. Here's u. Respect u first. 1/2. This means 1/2. U is negative 1/2. V is negative 1/2. Okay. Respect derivative, it's u. It will be v. Here is negative 1/2. This means negative 1/2. U will be stay. It's 1/2 power. And v will be negative 1/2 minus 1/2 minus 3/2. Okay. Here is y respect u. It will be 1/2. U is 1/2. U is negative 1/2. V is 1/2. And for v it will be 1/2. U is 1/2. V is negative 1/2. Okay. Evaluate, counting your diagonals. U is cancelled and v will be negative 1. This means 1/4 v negative 1 power. Second diagonal and we need subtract. This means plus 1/4 v. U is cancelled and v is negative 1 power. 1/4 plus 1/4, this will be 1/2, 1 over 2 v. Great. Now we're ready, finally, we're ready for write our integrals. It will be, okay, first time little bit clear. Okay, I'm save my Jacobian, it's 1 over 2v, and then I clear here how I'm counting. Okay. Start right. We have integral. How it's u changing from 1 to 4? How is v changing from 1/2 to 2? How our function, what we have here? We have product x and y. Product x and y give us u. This means e to the negative u halves. Okay, guys, it's u, it's not 4. Now we have our Jacobian, 1 over 2v, and then we have the u, the v. Because, the v du, sorry. Because u changing from 1 to 4, here is, I need checking, it will be v here and u there. It's no big deal, our function is not depend. You see, piece of function is not depend. Okay. Then we have integral from 1 to 4 e to the negative half of u power, and 1 over half. We can write 1/2 there. And the v over v, it will be ln v. Whereas we plugging for v, it's 1/2 and 2 du. Okay. And then we have natural logarithm v. It will be, okay, 1/2 integral 1 to 4 e to the negative u over 2. And then we have ln 2 minus ln 1/2 du. Well, how you remember ln 1/2? It's minus ln 2. This means here we have, if we simplify, you have 2 ln 2 over 2. It's cancelled. And then we have, because coefficient u in the power negative 1/2, this means we need e to the same power what we have, you have, you need divide negative 1/2 and plugging 1 and 4. It will be minus 2 ln 2. Here we have e to the negative square minus e to the negative 1/2. Okay. Well, I think it's good enough. We finish. If you have in the book little bit different answer, it means you need more simplify. Okay. Good. If you have any question, please write me, and I write when we're doing office time. I think it's Thursday and Friday. Okay. Bye.